video on conversion between the moles of a gas and the volume of the gas at STP, we use molar volume for these conversions. This one as a factor, as a conversion factor. And here is the equivalent. 1 mole equals 22.4 liters. This equivalent gives us two fractions, and both these fractions are valid. And they are saying the same thing, that any gas at 1 mole of gas sample will occupy 22.4 liters. Okay, it could be any gas, and if it is 1 mole, it is going to occupy 22.4 liters of space, provided there is a condition, provided the gas is at STP, meaning standard temperature and pressure, which is 0 degrees Celsius is the temperature and 1 atmosphere is the pressure. So STP standard temperature and pressure is very important for gases for this equation to be valid, to be correct. This is true only for gases at STP. All right. And why is that? Because volume of gases varies with change in temperature and pressure. Now, out of these fractions, which fraction are we going to choose for our problem? We're going to pick the fraction that has the ending unit in our problem, whichever ending unit, meaning the unit that is required, asked in the problem, is at the top. So if we are asked to convert from volume to moles, we're going to use this one, ending unit at the top, starting at the bottom. Similarly here, if we are to convert from moles to volume, we are going to pick this one because ending unit, liter, which is for volume, is at the top. So they both are conveying the same information. It's just, you can see, it doesn't matter which one goes in the numerator and denominator, they are still the same. It's just written inversely. And the unit for molar volume is liters per mole. Let's understand this with the problem. Find the volume of 5.3 moles of carbon dioxide gas at STP. So in this problem, we are asked that how much space, because it says volume, how much space will 5.3 moles of carbon dioxide gas take at STP? How much space is it going to occupy? Well, we already know from the definition that at STP, 1 mole of any gas occupies 22.4 liters of volume, 4 liters of space, right? Now this gives us two fractions. It could be, we can write this way or we can write it this way. Both fractions. Now, which one are we going to pick? So let's start with the given. 5.3 moles of carbon dioxide. Okay, just write 1 at the bottom because it just shows us we are dealing with the fractions, working with the fractions. Now we want to get rid of moles, so we are going to pick this fraction because this fraction has moles at the bottom. So 1 mole of carbon dioxide, we're going to cancel this since we don't want that unit. All right, this is the one we want. So that is how you start out with the given, and guys, then you set up the fraction here, draw a line in the middle, write the starting unit at the bottom and ending unit at the top, and cancel the units which are same, the numerator and denominator. Use your calculator, plug in the values, and this is what you're going to get. Move the decimal 2 places left for the correct scientific notation. Okay. Now here 1 and 2 sig figs, so we have to round off here. This will give us the answer. And then liters, don't forget the unit. It is important that you write the unit. So if you were asked to explain, or you were asked to explain in writing, how would you convert from moles of a gas to a volume of a gas, you would say, to convert from moles to volume, I will multiply the given moles, okay, the given moles by the molar mass, molar volume, okay, it is molar volume. Now, if you're asked why would you multiply by molar volume, why not divide, then you would say you would multiply because by multiplying by molar volume, this cancels out the unit that you don't need. We don't need moles and moles. And this just leaves the unit that we actually need in the final answer. And what I needed was liters, the volume. All right. Okay. Now your turn. I want you to try this. So you're going to do the same thing. 1 mole equals 22.4 liters. You're going to pick the fraction which you think is going to cancel out the units that you don't need and which is going to leave you with the units that you actually need at the end. So how much space will be occupied by 128 moles of methane gas at STP? Okay, so now you set up the conversion, like which fraction are you going to pick, because it is asking you how much space, meaning you have to find the volume. That means the fraction with the volume at the top is the one that you're going to choose to solve this problem. So start out with given. What is given? 128 moles of methane, and then you're going to follow the process. Divide, just put 1 in the denominator, make it looks like a fraction, and then you're going to pick this fraction here with the desired unit at the top. Cancel the units, top and bottom the same units, you want to get rid of them. And then you multiply these numbers, you get this answer. You change it into scientific notation, moving decimal 3 places to the left. So that's why you add it to the exponent, and that's what you got. All right. Oops, I forgot the significant figures. Oh, well, here 1, 2, 3. So you are going to 1, 2, 3 right here, and the final answer will be this one. Okay, and you have a unit. Right. Let's solve this problem. A chemical reaction produces 0.40 liters of nitrogen gas at STP. Now you have to determine the number of moles of nitrogen produced here. So in this problem, we are to determine the number of moles of nitrogen gas, right? Meaning we have to find the moles. So let's start out with given 0.40 liters of nitrogen. Okay. Now which fraction am I going to put? It says determine the number of moles. So I want the moles at the top, and I want my liters to be cancelled. So this is already defined. Okay, and I'm going to write nitrogen because we are talking about nitrogen gas, even though it's true for any gas, but you always write the substances you're talking about. All right, now you use your calculator, divide them, you're going to get this answer, and 1, 2 places to the right for the scientific notation, and 1, this is a placeholder, so 1 and 2 here, right here, round off there, and this is your answer, and moles of nitrogen. Units are extremely important, guys, because if you don't talk about the units, then these numbers don't show anything. They don't mean anything, because measurement has to have the number and the unit both. So to convert the given volume to moles of a gas, what would you do? If you are asked, you're going to say, we multiply the given volume, because it is liters, so we multiply the given volume by the inverse of molar volume. Okay, or you can say we divide the given volume by the molar volume. Either way is same. Now if you are again, then you're further asked, then why are you writing the inverse of the molar volume? What's the reason? Your answer would be because you have to set up this conversion factor in such a way that cancels out the units that you don't need and leaves just those units that you do need at the end. That is the reason you have this written inversely. Okay, so liters gets cancelled, mole is the one you needed, and that's what you are left with. Okay, so did you notice that 22.4 liter is a very important is very important number to know when you're converting between moles of gas and volume of gas. And again, guys, this 1 mole equals 22.4 liters is true only for gases at STP. All right. So this is not going to be valid for liquid or solid. Those problems are solved in a different way. So it's valid only for gases. So here I would like you to try this problem. Follow the same process. Now here they're asking, so you start out with the given, what is given in the problem. Write the equivalence first, that 1 mole of gas is 22.4 liters of gas, and here they are talking about the gas SO2, so you can write that SO2. Then since you have to find moles, you're going to multiply your given by the fraction that has moles at the top, all right, and liters at the bottom. So here you go. You cancel the same units, then you divide these numbers, that will give you this number, and it's already fine with the scientific notation. So you just fix the significant figures. 1, 2, 3, 1, 2, 3 right here at 6. Next number is 4. So this will remain as it is. Okay guys, I hope the video was helpful, and if you would like, you can use the mole map. That's up to you. Okay, thank you so much guys. Thank you for watching.